So maybe we should get started, and if Todd joins, that'll be good. But yeah, so just let's start out with a few administrative notes regarding TPAC. We need to subscribe for days. We're gonna go for 2 days as usual. We're probably gonna go for Monday and Tuesday, but we were wondering which groups we should ask for, like to avoid conflicts with. I heard from Marcus that he would like to avoid CSS and Houdini meeting conflicts. I can ask for that. Any other conflicts we should try to avoid? Ryosuke, specifically, as I know that last time around you had many conflicts. So
Well, yeah, I mean, I like to avoid it with web apps,
web
or rather,
apps.
web platform, web platform.
Okay.
It'd be cool if you could avoid a service worker too.
Okay.
Actually, you should say web apps and web platform.
What?
Web apps working group again?
Yeah, there is a proposal for that.
Oh no. Okay.
I can point you to it if David didn't do so yet.
Okay.
Okay. Okay, so we can try to avoid those conflicts. There are no guarantees there, but we could ask for it and see what happens. So, yeah. Cool. Otherwise, in terms of the next call, I will be traveling for 3 straight weeks, starting from like not next week, but the week after that. So the only option that would kind of work for me would be Friday, like 2 weeks from now. So Friday, March 29th. Would that work for folks, or okay.
28th should be okay.
29th. So 28th, I'm
29th, sure. Yeah.
okay.
29th, sure. Yeah.
Okay, so
29th works for me.
Okay.
cool. So let's set the next meeting for March 29th.
Hey, I'll miss that meeting, but please have it anyway.
Okay.
I'll be out of town, and I don't want to have it move again.
Yeah. Okay, and with that, I think we can start the actual agenda. So, Ilya, you wanted to talk a bit about sign exchanges?
Sure. I guess I don't have a proposal. This is more a question to the group. This came up in a couple of discussions on some of the internal mailing lists. So I want to get a pulse from this group. So the observation is Chrome is shipping signed exchanges, and if you're not familiar, the general idea is you can wrap an HTML document into a signed exchange that can be served off some CDN edge that is not your origin. And when the browser fetches that signed exchange, it will verify the identity and present the URL as if it's coming from the actual origin. So one particular problem it solves is the AMP cache or AMP documents, where currently they're being served off Google Cache, and they have the AMP cache CDN, and we would like to show the actual origin of that page. That's one of the use cases. So if that's a platform primitive, one interesting question is, what implications does that have for performance telemetry? Because now your document can be served off the origin, and it can also be served off some CDN edge. And presumably, the performance characteristics might be significantly different because the CDN cache is closer to the user or has some different characteristics. what does this actually mean for our performance APIs? For example, in the network error logging API, we actually recently added some changes that would allow you to distinguish when a signed exchange failed to load. So that's one example where one of our performance APIs is already providing some telemetry about it's not just that the navigation to your origin failed, it's the signed exchange that failed to load. What about something like navigation timing, for example? Would or should navigation timing actually expose some new attribute or new information about the fact that this particular navigation is actually for signed exchange and is meaningfully different?
Could you like explain what the signed HTTP exchanges are in slightly more in detail? I'm still not following what this feature is about.
Sure. Yo, do you want to give it a try or?
Sure. So sign exchanges enable us to take a resource, wrap it up with a sign exchange format, add a header that includes the signed digest of that content, and from that point on, we can serve that resource from any random origin on the internet, and the browser can still verify that this content originated from that original origin and wasn't tampered with. It doesn't provide the same confidentiality guarantees that TLS gives us, but it does give us those authenticity and tamper-proof guarantees.
Okay, so this is about, so let's say you have an A.com, and then you can send a request to B.com, and the B.com can have wrapped content for A.com.
Yes.
Signed.
Yes.
Oh,
signed by A.com, and it is like one of the requirements is that it's non-credentialed content. So this is just
yeah, sure, yeah. Otherwise, it will not. Yeah.
Okay.
Just to confirm, is this what was talked about at Dev Summit as web packaging or?
Yes.
Yeah, web
this is a
the
part of web packaging. Yeah.
Yeah. Okay.
Can an origin block this from happening for their content?
An origin has to actively do things in order for that to happen to their content.
Okay.
Yeah. But take an example of, I'll pick on AMP just because it is a concrete use case. So if today you have an AMP website, you can implement a signed exchange, or you can provide a signed exchange to one of the edge caches. The edge cache consumes that and serves that to their users. So for example, when a user on Twitter or on Google search clicks on a link that links to the signed exchange, the exchange is loaded off the CDN, not off your origin. And because it's signed, we can verify the authenticity and present the URL as if it came from the actual origin. So we would present the origin's URL. But the implication for performance here is, what do we say, if anything, if you have your performance telemetry collecting data about, should we distinguish these cases? Should we expose new information about this particular load happened off a signed exchange, and that should be a dimension in your run telemetry or not?
Well, hang on, but how does browser know to send a request to the edge server?
So a platform like, let's say, Twitter or Google search would know to point to their edge cache. So concrete example with search, we crawled the page. During the crawling, we identified that you advertise support for a signed exchange. Our cache then picks up the signed exchange, puts it into our cache, and in the future, when the user clicks on the link, we direct you to the cache version.
Oh, I see. So from this example, in IETF proposals, edge server itself is the one that claims it has a content for some other server?
I'm not sure I followed that. Can you say that again?
So in the previous example, if you have a.com and b.com, b.com contains the signed content for a.com. It's that the browser will send a request to b.com first, and then the b.com is the one that advertises that it has a content for a.com instead. Is that right?
Yes, the user initiates a click that goes to the cached version. That cache can be, how that cache discovers and pulls in the actual signed package is kind of a whole other mechanism, but somehow like you land on a page that links to a signed exchange that is hosted by a cache.
Okay, and there's this like extra CDOR representation, but like, is there some sort of a check to the original server that it's authentic content, like, or no? Like, how do we verify that it's signed by the original?
So I think we're getting into the weeds of the actual signed exchange, which would probably be a good thing for us to review, but I didn't want to take too much time on it.
Right,
it's signed content, so we do verify, like, basically, we verify the authenticity and verify that the content hasn't been modified. As you have said, we don't provide, that doesn't provide the confidentiality, a guarantee that CLS does, but it decouples the identity from the end-to-end confidentiality. And
I understand that, but I'm asking more about from network mechanics, right? If, for example, if it's sending an extra request to original origin to verify, that would affect how resource timing, navigation timing have to handle this, right? So it's kind of relevant as to like knowing how that verification is done if it involves network requests or not.
So right? It does not. So the browser doesn't verify with the original origin that the content is authentic. At least that's the... There are discussions about doing such verification on some bases, but there are trade-offs there when it, like, between user privacy and having a quick way to verify that the content is purged. So the browser knows that the origin has signed this content within the last few days. That is something that the browser knows. It doesn't need to re-verify that with the original origin. But there can be cases where the origin has signed a typo and then tries to revoke it. So there are mechanisms in the caches for making that kind of purges and making those verifications. There are ongoing discussions whether or not the browser should also do that kind of verification.
But like, if I haven't never visited origin, how do I even know?
It's signed by the origin's private key.
But I mean, if I don't know even the certificate, how do we like?
So you are down. The certificate is downloaded. So you are downloading the certificate, but not necessarily from.
So I think that's what Ryosuke was asking. So there is some verification.
Yeah.
So you know what? Let me just pause this. What I'm hearing is, it sounds like what we should do is draft, like do a little bit of an audit and draft a summary of how this works, and think through the implications for resource timing and navigation timing. I was hoping to get like a quick gut check, but I think we need to do some groundwork before we can even do that. So I can take that as an AI.
Yeah, I would say the gut check is we definitely need telemetry for this situation to distinguish it. Are these signed packages including media content like images and video?
As of today, no. It's for the HTML document itself, but in the future, web packaging broadly, I think, is inclusive of potentially
potential for media content in these signed packages. It definitely needs distinguishing telemetry.
Okay. All right. Thanks, folks. I'll try to pull something together and circulate to the group so we can review it in one of the future calls. Thanks.
Okay. Cool. So Nicholas, shall we move on to element timing for text elements. Do you want to present or?
Yep, I'll present.
Okay.
So we've already presented briefly element timing for images. This is more focused on text. The idea is that we're going to expose entries for important text components of a website. So brief recap. Right now, the element timing is exposed as a performance entry, and it has 3 additional fields. This has changed since the last presentation. The intersection rect is the intersection with the viewport. Response end is the image's resource response end, so it comes actually from resource timing. And identifier is the element timing attribute value. We've decided to change name to be the resource timing name, just for consistency with resource timing. So for image element timing, we want to expose image elements, images that are inside an SVG, poster images of videos, and background images. The weird case there is background images because they are not DOM elements. So the way you would expose them is you have to observe the DOM element that is affected by the CSS property that contains the background image that you're interested in. When you do that, you will get 1 entry per background image that affects that element. Again, to recap, for images, we have 2 types of registration. We have developer-led registration, which is basically just set the element timing attribute to some value. And the second one is automatic, I'll call it automatic registration, which is when the image occupies a significant portion of the viewport, then we dispatch an entry corresponding to that image. So now that I recapped how element timing is working currently for images, let me now propose how it would look like for text. So the first problem with text is that text nodes are not elements. So we want, well, in addition to that,
Sorry, before going to that, can somebody post the URL for element timing? Oh, sorry.
What? Sorry, what? Here?
Is there like a spec text for element timing now?
There is. It's not in W3C though. It's in WICG.
Okay.
So because it's still being worked on.
Okay. Could somebody post a link somewhere?
Oh, sure. Can someone?
Yeah.
I just said it's on IRC, Ryosuke, if you are on IRC.
Sorry, I am not on IRC. Let me.
Where do you want it to be posted in that case?
Could you post in this Hangout chat?
Yes, if I can find it. Ah, here is a chat.
Here you go. Yeah, I'm also adding it to the minutes.
Thank you.
All right. So I should note that the text component has not been added to that. So the WICG link is just for images. So right now this is like a fairly recent proposal to add text and wanted to hear some thoughts about it. I wrote an explainer about it. There are still things that need to be worked on. The main controversial thing is how to aggregate text nodes so that it makes sense for an entry to correspond to a cohesive set of text within the website. The problem being that usually there is some hierarchy between the element and text, be it via spans, divs, and whatnot. So we plan to do some research on this by looking at a corpus of websites, probably Alexa top 10K websites, and see what would make sense for those, and then propose how to define which text nodes belong to which DOM elements.
So a really concrete example of the problem here, if you have a paragraph that contains some bold text, and suppose that the bold text uses a web font, and that web font is slow to load, if you are looking at element timing for that paragraph, should it wait for that bold text to be displayed or not? And so we're currently trying to sort of reason through that, but the fact that you can have this sort of hierarchy of text and you don't really want to have to wait for everything to be done is where we're running into problems. Does that issue make sense to people? Do people understand what we're talking about there?
It makes sense. I think maybe a reasonable approach would be to take the similar coverage approach of images on the whole viewport and to apply them to elements. So if an element has text that is rendered and some text that isn't rendered, it's fully we can say it's rendered when some percentage of its text is rendered. And I don't know what that percentage might be, but that could be an approach.
I think even if you just say 100%, I don't think that would behave incorrectly, really. I think we had some concerns about the performance of monitoring all subtext. Nicholas, is that right? Or
yeah, the idea being that ideally we'd like to not allow things like, I don't know, set an element timing attribute for your body. And then basically you'd have to wait for all of the text to be rendered and so on. Because this will involve computation of the bounding boxes of the text. I'll explain that a bit later. But I think the question here was more about how the belonging should work. And by belonging, I mean which text node should be considered for which DOM elements. The question about rendering is a separate question. Okay. So this is first the question about for a given element, what are the text nodes that this element cares about? Of course, one answer could be all of them. So basically all of the ones that are contained in the element, but that could, like I said, I'm worried that could be performance-wise not great. And the problem is not just if a developer sets silly element timing values, but also because we worry about automatic registration. We want automatic registration for text as well. So a lot of these computations have to be done regardless. And so we want them to be efficient. And so in particular, saying that a text node belongs to all of the DOM elements that are contained in it would mean that you have to do a lot of computations. So that's the problem.
Could it be the first text node of the element?
Sorry, could you say it again?
I was going to. I was suggesting maybe you want the first text node of the element.
The first, and no. So, for example, consider a paragraph that has links and maybe has some bold text and so on. You don't want to just look at the first.
Well, in that case, you need to aggregate them, and you're back into your performance issue.
Yeah, I think the concrete example where the first doesn't make a lot of sense, consider two headlines that are 2 words each. The first word is bold, and the second word is bold. It seems kind of, and say the bold text loads slowly. It seems kind of strange to say that the one is significantly different from a performance perspective from the other. The other option that we're kind of considering is, can we bound the depth that we consider text nodes to belong to elements? Maybe we only allow, say, 1 level of nesting or 2 levels of nesting, and maybe that's sufficient. And that's where we're planning on doing a little bit of investigation. So maybe we can say 2 levels of nesting is sufficient to handle 98% of real cases on the web, in which case we could argue that maybe that's a reasonable approach.
Right. And another proposal that came up was looking at certain DOM elements that are categorized as phrasing content. I believe I had I believe it is in the explainer. If you want to.
Can you repeat that? So what kind?
They're called phrasing content. Phrasing, which is more or less what we want, basically text content. But I think this needs to go under some research in terms of looking at websites, because it's kind of hard to reason about it before that. So I was just wondering if anyone had any clever ideas that we could use, that we could explore as well when we do this research. But if not, then we'll go with it and see what happens.
So I just read over the explainer when I saw this slide. As far as I can tell, it appears the way that you guys are breaking down the problem and thinking about collecting data seems like the right set of decisions. I think your core question is for folks on the call to
some finite depth. If we can show that some finite depth covers the vast majority of the use cases, does that seem like a reasonable solution to the working group? Or every 2,000 sites where this doesn't work correctly, we should find a different
X locations, depth of DOM tree is completely irrelevant, right? Like the tricky case is the overflows and clipping, and text wrapping and so forth. Like computing a bounding box's text is notoriously expensive because of that. I don't think limiting based on DOM tree depth will solve any problems.
It reduces the set of elements that we care about as potentially being large.
Yeah, I mean, but a few elements you have maybe pathological cases, which can involve doing basically full page layout to figure out how big each text is. I mean,
yeah. So in these cases, the element timing entries would not be surfaced until after the content is already laid out, right? And so if the content is already laid out, then presumably we won't have to force giant layouts. We should just be able to use the size at which that content was already laid out at.
Well, sure. I mean, okay. But even in that case, then we have to compute the bounding box space by combining all the racks from each element. So I don't. I don't see how, like, in a case where all the text is embedded inside an element, we know that, like, when we're painting, right? So it's pretty inexpensive. What's expensive is the fact that now, like, whenever this thing is set, we have to remember for the fact for that element, and we basically, keep combining the rect whenever it overflows. So it's really the overflow that's expensive, right? If we can ignore all the overflows, this is easy.
Right. I think we'll have to give that some more thought. That's a good point.
I have a question. Did you take into account CSS generated content?
Yeah, so that's a problem because our idea is to. So let me explain how the render timing would work, because I guess that's kind of related to that. So assuming we know how to define what it means for the text node to belong to an element, we propose that we use the time when all of the text nodes have first painted for a particular element as the render timing, or the text render timing for the element. So in particular, if you use fallback fonts, if you're using web fonts and you have fallback fonts, then you would not necessarily wait until the web font has loaded, because the first rendering would occur with the fallback font. Now, this is relevant to your question, I think, because an element, for an element to be considered rendered, we just need to wait for all of the text nodes to have rendered the first time. So in the case where content is injected asynchronously, then that could be a race condition, if I'm understanding correctly the question.
But CSS generated content is not generated asynchronously. I think it would generally be part of the element and could be treated the same as text, which was sort of naturally within the element.
Right. If it's CSS, then yeah, I think CSS affecting an element is parsed synchronously, so it will just append to the DOM. I was thinking about JavaScript content. That would be asynchronous, if that's so for the script to run itself, right? So that is a problem which I think is not very common. So I think it's okay for that to be the case. So basically, we just consider the element rendered when all the text nodes have been first rendered. Does that answer the question?
Yeah, that's fine. I mean, you have to be clear about that. That you're not. It doesn't matter how long it takes to display the CSS generated content.
We should call that out.
Okay. So we want to define the size. This is relevant only for registration, automatic registration, which means that which elements are considered important, those will have an element timing entry dispatched regardless of if there is an element timing attribute or not. So for that, I proposed just adding the sizes of the text nodes that belong to the element. Other options would be the size of the element itself, but it feels like much less accurate than the text node sizes.
And in particular, you're not talking about intersecting the bounding boxes, but just taking their sum for performance reasons?
Yes. So, yeah, so it would just be sum of the areas, basically. And yeah, they could potentially overlap. But But again, I think in the majority of cases, it would be close enough because usually you don't want your text to overlap with itself. The other
is the size like a pixel value or a percentage value of the viewport, or?
Yeah, I guess that's the same question as for image. I know there was a proposal to use something different than percentage of the viewport. But so far, I think for image element timing, we haven't moved away from that. The reason being that considering like some other proposals would involve setting a cutoff point of when we stop looking, which I think is not ideal. But yeah, that's a good point. The question of which elements are considered important by themselves is still open for debate. But right now, yes, we're using percentage. Does that make sense to use the same cutoff for text and image?
Why not pix?
Why not what?
Pixels. Why not pixel value?
Pixel values? What would be an important pixel value?
Huh?
The reason is we want to set some threshold beyond which we consider elements important. And that may not be, if you're thinking about different device form factors, for example, saying like 900 pixels squared or bigger is important, might not translate well across different viewport sizes.
I mean, what happens when a user resizes the window?
The element timing entries would state the, well, we would use the fraction of the viewport at the time when the element was first displayed.
Yeah. So I guess if the viewport is resized and then you scroll down and then you see an element that occupies all of it, then it would be considered important. Yes.
I think there are some cases that are tricky around that we have not adequately considered, so we'll definitely think about that.
I think the window resizing is definitely a thing that needs to be considered. I mean, like, in particular, it seems odd that if the user were to resize while a page load is happening, then these values would be completely, like, fluctuating. I mean, that would not be okay. Like,
yeah, we should give some more thought to that.
Yep. Okay. So the other information is the intersection rect. That is just the base. I didn't have a great idea for this one because the element can contain a bunch of text nodes that are spread all over. So I just went with basically the smallest rectangle. Oh, that should be smallest. Sorry, that's okay. The smallest rectangle that contains all of the text nodes belonging to the element. Another option would be to expose all of the rects, basically one for each text node. I don't think that provides a lot of value. It's probably more confusing to have all that information exposed in the entry. And I think this works in most cases. If you think like a paragraph or a title, it works fine. For more complex elements, it will obviously overestimate. But yeah, if anyone has thoughts on this too, then what happened? Oh, I think I'm done.
Yeah, I think that computing a rect of text is actually very expensive. So I think That's the problem. Computing a random element is faster, right? I mean, basically, I think we can't do a thing where we compute the bounding vector of almost every element, to figure out if text is visible or not. I mean,
yeah, and so I think the explainer does call out that there are going to be some like clipping and occlusion cases where we do report that text is visible when it's not. I think for the primary use cases, that's fine. But you're right that we do need to reason through the performance.
I mean, maybe what we need to do is just completely forget about text and just consider the element box and just use that instead.
Yeah, but
that is an option. Yeah.
One concern there is you often will have a large element with a tiny amount of text in it. And so I think in a fairly common case, we would report that the important text is not that much text.
Yeah, obviously we want to reach trade-off between the correct balance between the accuracy and but without regressing performance in any significant way, obviously. But yep, that's a good point. Any other thoughts?
Okay, so thank you for that, Nicholas. I think that if there are no further thoughts, maybe we can move on to the next item of discussion, which is also presented by Nicholas.
Oh, yes. So I wanted to, I guess, point out to the comment I made on the performance timeline issue that is linked there. If people can go over there, it's in case you're not following the agenda, it's issue 81 of performance timeline. So the question is how to handle buffering once we ship the buffered flag. So again, to recap, we want the buffered flag because we want to encourage people to use Performance Observer because it's more efficient than just getting the entries on the script right away, because then you can't do any. But basically, Performance Observer would allow the browser to dispatch the callback whenever it's idle or whenever it thinks that the work can be done without affecting the user. But right now, a big flaw with Performance Observer is that we don't expose entries from the past. So the buffered flag attempts to tackle that. So with Tim and Yoav, we had a discussion a while back about how to allow the buffered flag. It basically requires some spec changes, and I wrote a comment which describes the proposal. So I'm wondering if people have thoughts on that, if they think that's fine, or
one of the key things that was hard to express without refactoring the spec was if we want to have new entry types, which cannot be gotten with performance timeline get entries, but can be gotten via registering a performance observer with a buffered flag. Previously, there's no real way of expressing that you would have some elements that are buffered but not exposed to get entries. And so we figured some refactoring might be worthwhile to let us express that.
Right. And the other the other problem is that obviously the browser itself still has to keep a list of the entries, so we still need to decide on a way to handle the size of this buffer, preferably without so much methods as we did with resource timing, which has the set size, the buffer full, and so on. So we had a concrete proposal to just agree on sizes, which will vary for each entry type, and basically only buffer until that buffer becomes full, and then if you have not observed the entries at this point, then they will be lost.
Would we also change the behavior for resource timing and revoke the current?
Yeah, that's a good question. In my proposal, I said basically keep resource timing as it is, because it feels like that would be a breaking change, and I don't feel like I feel like developers would not like that, to just out of the blue change the behavior so much, because resource timing already does their own buffer handling, which is visible to developers. My proposal is more about new entry types, or the ones that don't have this kind of behavior right now, how we would handle them. So think about, long tasks, I guess, is a special case. Right now we don't buffer them at all, but in the future with header registration, we may want to do that. We probably want a size for the buffer of the long tasks. And for event timing, element timing, which we're proposing, we'd also like to have a buffer of a specific size, but one that does not add so much methods, which...
So go ahead, Philippe.
So you have a buffer for each entry type, which sounds fine. But then you say you may not make this buffer available for all of the types.
Right.
In the current algorithm, we have a flag that basically allows us to say, add this entry into the buffer or not. So I'm just trying to understand why you didn't keep that mechanism.
Sorry, let me try to find the flag you're mentioning.
So the tricky case is where we want to expose the with the buffer via get entries. Right now, there's a flag that says, should we buffer it? And then if it's in the buffer, get entries will return it. Mm-hmm. We want the ability to have things which are in the buffer, so they'll be returned by a performance observer with the buffered flag, but will not be returned by get entries.
Oh, right. But the add to performance entry buffer flag, I would believe, doesn't impact performance observers.
That dispatches to the performance observers that are registered at the moment when the entry is created, right? But if you have a performance observer that observes afterwards, that entry was not added anywhere, so it will not be dispatched to that performance observer. So the buffered flag intends to solve that problem.
Okay, all right, makes sense. Thanks.
So, reading your rough breakdown, I think everything you've stated makes sense. It'll be hard to know for sure until I read the final spec and see how it fits together with the other specifications.
Right. So, yeah, I just wanted to know if people feel like the plan makes sense. Right now, we haven't done a PR, so for sure we'll add you as a reviewer, Todd. So,
Liz, could you just briefly recap? So let's say I'm creating a new spec. I'm making some new thing. What is our guidance now, or how you should reason about get entries or not? what would be the templates that would give?
A good question. I don't think I specified that very clearly in the proposal. So I think
this proposal doesn't actually have to solve that question. It's sort of a corollary question that.
Yeah, I'm just trying to think kind of into the future. How do I project? Right. What is the thing that we're trying to drive towards? Are we trying to drive people away from get entries?
Yes.
Or something? Okay.
Yes. The new spec would probably have to append some parameters when you do the calls to add to this entry. It would have some parameters saying, is this entry added to the performance timeline or not? And if is this entry? No, I guess we would always buffer it. So the other thing, the new thing would be, it would have to provide a maximum size for the buffer that is available to the browser.
So maybe part of this spec change should include a like, here's just a brief snippet of what integration with this buffer system is supposed to look like as a non-normative note.
Yeah, it may also just be like a document or something that we need to draft as general guidance. Because I think what I'm hearing is we want to drive people away from get entries. So if I'm onboarding somebody new, like writing a spec, the guidance would be, you should be using Performance Observer first of all. Like that's your bread and butter. But Performance Observer does not address the initial load use case where you have to register it. So for that, we support some buffering capability. Your responsibility is to specify the number of events that will be buffered. And if the subscriber passes in the buffer flag, they'll be able to retrieve that. But the implicit assumption is that by the time that buffer should be large enough such that you should be able to register a performance observer to have the full picture, right? When we say nothing about the global get entries and all the rest. Basically, we're saying get entries is a legacy thing that we're trying to migrate away from. We will have to support it for some of the existing APIs, but that's different.
Yeah, well, I guess if you have an API that returns a single entry per page load, like we're okay with having get entries for that, I guess, but it's not really necessary.
Yeah, I think we should just be consistent. And
yeah, for the sake of clarity, I think we should just like say, this is the new way, just do it, because otherwise we'll have to carry this legacy confusion forever.
Yep, and if we want to have the new Performance Observer as the new API, we should be, so we've declared that buffering solves some existing things, aka navigation timing, resource timing, etc. But it is also, might be that you need something like headers or HTML in the head, or meta tags that set these buffers. It may not be that the default buffers are sized. That's another way to think about this.
Yeah, I was imagining that we would have default buffer sizes that would meet most needs, but if you have a page that knows that it has just a huge number of elements that it wants to monitor or something like that, it would be able to, in the header registration, set the size of the buffer larger than normal. Element timing might not be the best example there, but maybe something that's a little bit cheaper to monitor.
It really, and that's the trick, is most of these things, it's going to be, we'll have a template, and then we have to apply the individual cases to the template. Yeah. Do they work? But I think we should kind of start with a rough template, and then apply the use cases to test it. At least that's how I think about it.
Makes sense to me.
For navigation timing, you only need, as far as I remember, an entry of 1 in your buffer.
Yeah.
Remember that get entries allow you to access entries that were notified before you had a chance to register an observer, by the way. So I don't think that we ever, I mean, correct me if I'm wrong, I haven't followed that closely lately, but I don't think we ever resolved the problem of what about entries that gets added before we even had the time to attach an observer.
So this is exactly trying to solve that problem.
Right.
So that's what the buffered flag to performance observer.observe does.
Okay, well, it's. I guess I would have to look at the proposal when it's better. When it's better fleshed out, because it's all depend on when when you're going to queue the entry.
We're getting kicked out here.
All right.
Okay.
Thanks, folks.
Thanks. Cheers.
See you.